Good morning, boys and girls. Today I'm going to discuss the topic kinematics for the first year topic, short way of learning practice. It is the most important topic in the mains examination as well as NEET examination. So, in this topic, what are the things we are going to learn? We'll discuss. The topic name is kinematics. What is kinematics actually? In this kinematics, what you are going to learn and what are the things you are going to cover. Actually, if you come across the case of kinematics, it is a branch of science which deals with the motion of the bodies and acceleration of the bodies and velocities, how it is moving, what way. That type of discussion can be done in the kinematics. Actually, kinematics comes into one of the branch called as mechanics. In that mechanics, kinematics is a part of that. So, total in the mains examination, mechanics 1, mechanics 2 are there. This is comes into mechanics 1. This is most important topic. Okay, in the competitive examination and NEET level, there is a certain level of approach of questionnaire if you practice. That's it. So I'm going to start the topic today. So first, classification we can discuss. According to the classification, mechanics is a branch of science. This mechanics is classified into three branches. One is called kinematics. Next one, dynamics. Next one, statics. In the kinematics, what we are going to learn? In the kinematics, we are going to learn about the body which is moving under the action of forces. No body will move without force, right? So here consider one of the mass body of mass m. I applied the force on this one with a F force. When you apply the force on any body, the body will move. So you know that, right? So according to the physics in this level, you have to understand first the body will move with a certain velocity, like right. So here we have different velocities are there. Initially starting, we are expressing as initial velocity u and final velocity v. After certain time t, velocity called final velocity v, and acceleration a, and in the time of t. That means after certain time, the body initially having initial velocity u that changes to v, and in this case it is accelerating, we are calling. Okay, these are the parameters which are involved. In the kinematics, what we are observing and what we are understanding is we are just understanding how the body is moving. Okay, how the body is moving. So either it is moving in a straight way or curved path, what is the expression of that motion of the body, that can be dealt in the kinematics. That means in the kinematics, we are not bothering about the mass and force. You take a small stone, throw it like this. You take a big stone, throw it like this. How it is moving, just we are looking at it. We are not looking at how much mass of that one, how much force we are applying on it. So without concentrating on the mass and force, whatever the things we are expressing in the science, that is called as kinematics. So that means U, V, A, T related terms we are going to discuss. Some more things are there, we'll discuss later. Dynamics. It is another branch of science, comes into mechanics. Here also same way, consider the mass body and apply the force on this one. So as per the basic, initial velocity u changes to v with acceleration in the time of t. Here also the body will move according to the way we are applying the force. But in this topic, we are not only understanding how the body is moving, at the same time, we are understanding how the body is accelerating. What parameter this acceleration of the body depends. So here, in this case, we are understanding what force if you apply, what acceleration is given. What mass if you taken, what acceleration is given. Means by considering the force acting on the body as well as mass of the body, we are expressing the condition of the body is called as dynamics. That means by considering the force and mass. Statics. It is the special branch of science which deals with the body. This is the m is the mass of the body taken, and it is under the number of forces. Under the number of forces, when it is acting, what happens? It may be equilibrium, it may not be equilibrium. Okay, so if it is equilibrium, okay, so that type of expression is different, and if it is moving, okay, that type of expression is different. So in this case, and here, if you come across a case of liquid molecules inside the glass, if you take a liquid, the molecules will move randomly inside, right? So one molecule apply the force on the other molecule. So this is the one molecule. Like if you say on this molecule, due to remaining molecule, there is a force is there. Not only in the case of liquids, in the case of gases also, we can explain the same thing. So statics can be applied to liquids as well as gases. So according to that one, the statics topic we are expressing as hydrostatics. Hydrostatics is a branch of mechanics, which deals with the body which is under the number of action of forces. So that is comes into hydrostatics, and also the complete topic comes into hydrodynamics also we are called. This is the basic classification. So in this our topic, our discussion is on kinematics, where without observing the force and mass, just observing the initial velocities, final velocities, accelerations, times, and distance covered, these parameters, we are understanding the calculation of the motion of the bodies and estimating the certain things of calculations in the science, right? Now we are going to discuss the topic kinematics. In this kinematics, we need to know certain terms involved in the kinematics. What are the terms we have to know? I'm not going to discuss detailedly because this comes into basic. First one is term rest. Second one is motion. Third one, we can come across case of distance. Next, displacement. Speed. Speed. Velocity. And acceleration. These are the terms you have to know before going. So anyway, just short while ago, I am at rest, right? And I can say according to science, I am also in motion. How can you say that? With respect to other planet, if you are observing me from the other planet, I will be in motion because Earth is always moves around the other planets. So I can say a body which is at rest also in motion, I can say. So this is one of the most important point you have to understand. So rest and motion both are relative to each other and according to the kinematics. Next, distance. The distance is one of the physical quantity which you are using to understand the concept of the body condition. Distance we are measuring in terms of s, or some books as x. It is one of the scalar quantity. Next, displacement is also similar quantity, but it is one of the vector quantity. We are indicating with arrow mark, s arrow. Speed is also one of the physical quantity, which is we are indicating with the letter v. It is a scalar quantity. Velocity is a quantity which is a vector quantity, that is related to the speed. Almost speed and velocity both are same. We'll discuss detail. Acceleration. Acceleration of a body is a vector quantity. So here you have to know well before what is scalar, what is vector. Then after only we can understand this topic of what is scalar quantity, what is vector quantity, what is distance, what is displacement, like that. So after the topic only we can able to cover. Now in this case, what I am going to discuss now. Now we are going to discuss directly. We'll go to the concept of distance and displacement. So first, if we come across a case of distance, distance is a scalar quantity. So it we are defining like this: a person started from I, that is called initial position, reaches to F, that is called final position. One person walked like this, another person walked like this. Now, how much length the person is walked? First person. This is called distance covered by the person, S1. Second person walked like this zigzagly, okay. And how much distance the second person walked? That is called distance covered by the second person. By looking at the diagram, we can say very clearly the length of S2 is more than S1. So I can say simply S2 is greater than S1. So the measuring the length of the path which is traversed by the person or object is called as distance. It is one of the scalar quantity, how much length he, okay, walked or passed, we can able to calculate. After this, we can go for the next topic, that is displacement. What is displacement? Displacement we are indicating with the letter S arrow. That means a person starting from initial position reaches to final position, and another person travel like this. Otherwise, that person only travel like this. Okay, one person actually started from I reaches to F. So this is the length of the path which is traveled by the person, that we are calling as distance S, like previous. It is the measure of length. But what is displacement? Simply statement, shortest path. Shortest means always, okay, the displacement is vector quantity. Vector quantity always we have to express in a straight line by drawing a line between initial to final point. This is the initial position of the person, this is the final position of the person. Take a straight line and indicate the arrow mark at the final position. Now this arrow mark gives the concept of displacement. So this length is called as displacement SR. So if you observe the diagram, the person actually started from I and he gone through this line and reaches to here, but this is the shortest part. If you observe the length of this one, this length is more than this. So I can say, okay, distance is greater than displacement in this case. In this case, right? So displacement we can define like this: it is the shortest path between initial to final position. So according to the observation of this example, we understand distance is greater than displacement. Is it possible all the cases? Means no. Okay, no means what is the meaning of this? Sometimes the distance maybe becomes equal to displacement, which case person started from initial and reaches to final. In this case, this is only the distance and this is only the shortest path, that is only the displacement. So both are same, equal. And is the distance will be less than displacement? It is not at all possible. Not possible, because distance always more than displacement, because the displacement is the shortest path. Next, if we come across a case of displacement is, okay, maybe equal to 0, displacement may be negative, displacement may be positive. This is most important point you have to understand. And according to that one, the distance calculation, if you say distance, the distance which you are writing, distance is never be 0 if the person changes his position. Distance never be negative, and the distance always positive. These are the most important points you have to understand here. So what way we can say positive, negative, that we'll discuss in a short way and we'll go further. Now, when will be the displacement will be negative? Person starting from here, he walked through some distance, okay, from here to here, first A to B I'm saying. Again, after he returns back from B to A. So what happens? Where he started initially here, again he reaches to same point, final. That is only initial, that is only final. In this case, the displacement of the person we can call it as 0. because there is no distance between initial and final position. The shortest path position between the initial and final is 0, so displacement is 0. So when will be the displacement will be negative? Person starting from one point initial, that is A point, reaches to B point in one direction. After that he returns back, and after returning he come back to somewhere. So in this case, person initially started here, finally reaches here. Initially he walked through positive x-axis. Later on he reversed it. That means this is positive, this is negative. So that's why this is called as displacement from initial to final position. The length is called displacement. That displacement we got in opposite direction of the actual direction. Actually he went to A to B, but finally come back behind the A, that is A to C, like if we say. So displacement is this value we have to indicate with a negative. This is the way you have to understand the concept of distance and displacement. Now I will discuss the one model problem in this. Take example problem. A person started from initial position. He walked towards the east direction by 3 kilometers. After that he turned towards north and reaches to one of the final destination, final position, by traveling 2 kilometers. Now the first question is what is the distance covered, and the second question is what is the displacement covered by the person. So according to the basic statement, the distance is always called as total length of the path. How much length he walked from here to here? 3 kilometers, and from here to here 2 kilometers, that is totally 5 kilometers is the answer for this. Now if you come across the case of second one, displacement. What is the meaning of displacement? Shortest path. Shortest path between initial to the final point. This is the initial, this is the final point. Shortest means always you have to take a straight line, because displacement is a vector quantity. Take a straight line directly to the F, and vector always, arrow of the vector always indicated at the final position. So this is the way we can indicate the arrow mark. This is the way we can indicate the arrow mark for this. This is the direction of that vector. Now this length we need to calculate. That gives the displacement concept. So what is the length of this one? The length of this one, if you observe this one, it becomes a right angle triangle. And according to geometry, we can apply the Pythagoras theorem. According to Pythagoras theorem, hypotenuse square is equal to adjacent square plus opposite square. So in this case, I can write the displacement vector is equal to nothing but 3 square plus 2 square. We have to apply the Pythagoras theorem. If we calculate that one, what is the displacement? Displacement is equal to under root of 3 square means 9, 2 square means 4. That is equal to how much you are going to get? That is equal to root 30. That is in terms of kilometers. If you want to go more precise answer, you can go with a more precise way. This is the answer for which question? That is related to first model. Next model. The next model I can say a person running over a circular track started from one position, that is P, you say. He reached to the Q, you say. When he was running on a circular track, he runs, you know that grounds, there are circular tracks will be there, they will do the jobbings like that. So on the circular tracks, the radius of the circular track is given. That radius of the circular track is given as you take it as 10 meters. Practicality based 10 meters like, So when the person completed 10 rounds, he made 10 rounds. After completion of the 10 rounds, if the person reaches to Q position, what is the distance covered by the person? First question. And what is the displacement of the person? So in this case, to solve the problem, person starting from P, so I am taking as initial position. Person ended his journey to the Q after making 10 rounds. That is the final position. So to calculate the distance, what is the distance? First question, to calculate what is the distance? Distance is nothing but length of the path covered by the person. So how much length of the path is the person is covering? When person started from P, again reaches to the P. The person started from P, again reaches to the P. In this case, when a person started from P, again reaches to the P. In this case, he completed one round, we can say. Like that, how many rounds he completed? 10 rounds. 10 rounds after that, he reaches to P point, but he reaches to Q. So that means after 10 rounds, again he travel to P to Q. So according to geometry, you know that this is the length of the circle. The circle length, okay, how much length? One round he made a circle means the total length of the circle is 2 pi r. How many times he ran on the circle? 10 times. So totally from starting from P to reach the P after 10 rounds, this is the total distance he covered first. And not only that one, he did not reach to P, he reached to Q. So after 10 rounds, he started from P again. That means he reached to Q here. That means this is the another half of the circle. Total circle is how much? 2 pi r. Half of the circle means how much? Pi r. This is the extra half circle he ran. So in this case, 2 pi r into 10 plus pi r. This total value, how much you are going to get? This is 20 pi r plus pi r, that is nothing but 21 pi r. So if you substitute the value of this one, what is the distance covered? Distance is equal to nothing but 21, okay, into pi into r value, how much we taken here? Radius of the circle is 10 meters. So that is nothing but 210 pi meters. This is the distance covered by the person with this. Right? Next question in this, one more, that is displacement. What is displacement? Displacement is vector quantity. First you have to understand. It is always taken in a straight line always. So circle is not a straight line, and always it is taken between initial to final. So this is the initial position and this is the final position. So you take a straight line from initial to final. I'm taking the blue color line, initial to final. This is the way you have to take, and keep the arrow mark at the final. So when the person completes one round, started from P, again reached to P. So in the case of one round, that is only initial, that is only final, means what is the displacement? 0. In the case of 2 rounds also 0. In the case of 10 rounds also 0. After 10 rounds, he started from P, again reached to opposite, means in this case, he is not in the initial position. Initial and final are not same. Initial is here, final is opposite. So this becomes the line which you taken from P to Q, that becomes the diameter of the circle. That diameter becomes shortest path. According to geometry, you know that this is the radius of the circle and this is also radius of the circle. The diameter of the circle is equal to, we can write 2 times of radius. So that is nothing but 2 into, what is the radius of this one? 10 meters. So 10, totally 20 meters is the displacement. So this is a way you have to calculate the problems, distance and displacement. Okay, the care has to taken, the displacement is always shortest path between the initial to final. Now we are going to discuss about the most important competitive concept, one of the concept. We'll go in a short way, which is most required, that will go in a deep way. So in this first, we need to discuss about speed. Speed we are indicating with this v with a scalar quantity. It's simple short way I can say, a person starting from initial reaches to final. This is the total distance covered by the person. The person covers the total distance. Okay, any person cannot cover the total distance at a time, right? So he is going to cover the total distance in small parts. The distance covered is, in the first small part is called as S1. This is S2, S3, so on. I can say as Sn. If total distance, if I divide into n parts, the person cannot cover the total distance at a time. He will cover the distance, each distance in small distances, S1, S2, S3, so on, Sn. He takes some time to cover the distances, that is T1, T2, so on, Tn seconds. Each small distance he takes some time, that's called T1, T2, so on, small interval. So the speed we are defining here, like what, okay, distance he is covering. That means distance S in the time of T is called as speed. That means if he covering the more distance in the small interval of time, that is called, the person is with more speed he is moving. So that means a small boy, big, okay, younger ones. Who will cover more distance means, okay, small boys covers only small steps. big ones covers in the same time, big persons can cover more steps. So I can say distance covered by the person, if it is more in the small interval of time, that is called as speed. Speed is a scalar quantity. Now this speed can be expressed in terms of simple formula based s by t. Also differential function based we can express, that is ds by t, because differentiation is one of the function we are using any physical quantity which is changing with another physical quantity. So here s is a variable, t is also variable, s is changing with respect to time. So that's why this is called differential function. I can write ds by dt. So speed is nothing but ds by dt. So units I am writing as in terms of meter per second and kilometer per hour. These two are the basic, right? So here we have a one understanding concept is the conversion of problem in terms of meter per second, kilometer per hour. So here you have to understand that 1 kilometer per hour, 1 kilometer per hour, 1 kilometer per hour is equal to 5 by 18 meter per second. Thus the relation you have to know, and you can able to apply while solving the problems. 1 kilometer per hour, how can you say that is 5 by 18 if you want to check it? 1 kilometer per hour means 1 kilometer means how many meters? That is 1000 meters by hour. How many seconds are there per hour? That is totally 3600 seconds, because 1 hour 60 minutes, each minute 60 seconds, 60 into 60, 3600. If you cancel these two zeros, there is 10 by this, and if you cancel with the 2 5s, 2 18s, that is 5 by 18 meter per second. So similarly, if the problem is given in terms of meter per second, and 1 meter per second is equal to how many kilometers per hour, means 18 by 5, okay, that is kilometer per hour. Reciprocal of this one you have to choose. These two relations compulsory you have to remember while solving the problems. Right? Next concept we are going to discuss about the speed. Sorry, speed is over now. Now we are going to discuss about the velocity. Velocity is a vector quantity. We are indicating with the letter V, and the velocity we are defining in the same way as distance, speedway. This is one of the person starting from I reaches to F in a particular direction. Then the total distance covered by the person in a particular direction we are indicating with the displacement vector SR. Now no person cannot cover the complete distance at a time. He is going to cover the small parts. So the smallest part what he covered towards a particular direction is called as displacement. So he is going to cover, the person is going to cover small displacements each time and reaches to final position. So the displacement of the each one we are calling as S1, S2, so on, Sn. And he takes the time interval T1, T2, so on, Tn. So total displacement time based on this. So velocity is a vector quantity. So we can define like this. It is the displacement covered by the person in the time of t. So total displacement by total time. Simply total displacement by total time. These are displacement. If you add all the displacement again, you'll get the actual displacement. So total displacement, total time is called as velocity. Now this in terms of differential function we can write as ds by dt. It is a vector quantity having particular direction. So it is also same units. Meter per second is 1 unit. Second one is kilometer per hour. So what is the difference between this and this? It is not having particular direction, it is having particular direction. Okay. Practicality, the velocity is a word we are not using. Mostly the velocity is nothing but speed, because when you are riding a bike, so what speed you are going? Your friend will be asked always, what is the speed you are maintaining the bike? So you can see the speedometer that gives a value of speed, not the velocity, because velocity indicates that magnitude as well as direction. So the direction will be always changes. That's why at that instant you can able to explain that velocity. That velocity, whatever you are explaining at that instant, particularly at that instant, whatever you are expressing, that is called as instantaneous velocity. That is one of the small concepts we need to, okay, discuss. What is instantaneous velocity? What is instantaneous velocity? Instantaneous. Instantaneous velocity, that is V instantaneous, VI. Instantaneous velocity is one of the parameter of explaining the velocity of object at any instant of time. That means person walked from started from time t equal to 0 and he covered certain displacements, number of displacements, right, in this case, and he after t is equal to 1 second here, after t is equal to n seconds here. Now if you are asking from this position to, okay, this position to this position at this moment, when vehicle is moving, suddenly you ask that what is the speed of your vehicle at that moment. This is the part if you are asking. So at this point if you are, okay, asking, so this value of displacement time, whatever the things, what is the speed you are expressing in this case, that speed we are calling as instantaneous speed. This instantaneous speed up to where you are going to calculate this value, you are calculating from, not from the starting, from here to just the previous instant. If you are asking the what is the speed of your vehicle, that is called instantaneous speed or instantaneous velocity. That velocity you are calculating from this point to just the previous instant of time. So that previous instant we are taking as 0 for this, and this is the time of t. This is the 0 for this, time of this. So whatever the calculation you are doing to the previous time of instant, that is gives the instantaneous velocity at any instant of time. So instantaneous velocity we are indicating like this. Instantaneous velocity is equal to, using limit function, limit delta t tends to 0. If you see this one, t, at this point you asked, but you are calculating up to 0. This difference in the time is called delta t. Here t, 0. This difference in the time is called delta t. So limit delta t, that means you have a limit up to here only. We cannot go up to here. So within that small limit, whatever the velocity you are experiencing, that is called instantaneous velocity. Limit delta t tends to 0. Limit delta t tends to 0. Change in displacement by change in time. Because this is one displacement, this is another displacement, right? S1, S2. That change value, how much change value? That is nothing but we can write as limit delta t tends to 0. Delta S means what? S2 minus S1 by delta t, t minus 0. Change in distance by change in time. This is nothing but called as instantaneous velocity. This instantaneous velocity according to the mathematically, which is equal to ds by dt, that is differential function of displacement with respect to time. So this is the way you can able to explain. And in the graph questions you can able to explain this one. After the completion of the graph you may can understand the question of this. Now we are going to discuss a concept, average speed, average velocity concept. This is most important for the problem sake. Average speed and average velocity concept. Average speed we are indicating with VAVG, average speed. What is average speed? Nothing but you started from your house, you went outside, again come back by on the bike or okay, riding the cycle or car, whatever it is. Your friend, okay, you were in the house, they will ask that what speed you travel, okay, ride the bike or car, like you will say one value, 40 kilometer per hour, one, okay, 160 kilometer per hour, 120 kilometer, like that. So what is the single value you are telling is the one of the average value. Yes or no? Because when you are traveling on a bike or car, you won't run the car or bike with a single speed. So number of variable speeds will be there. So the single value of speed which you are expressing, that is called average speed. What is average speed? How we are going to express the average speed? Average speed we are defining like this. Average speed we are defining. What way? Average speed nothing but it is the ratio of total distance by total time. Suppose a total distance, one person walked completely through a distance of s. He cannot cover the total distance with a, okay, at a time, right? So already we discussed. He can cover this total distance into small parts. That distance is called S1, S2, S3, so on. That is nothing but called as Sn. And the times of T1, T2, so on, Tn. So no person can cover the total distance at a time. Now, each case is having speed. Here speed is V1, here speed is V2, here speed is V3. So the speeds are maybe same, may not be same, right? So he is going to cover the distance with a different speed. So average speed we are defining like total distance. How much total distance? S1 plus S2 plus so on plus Sn covered in the total time. That is T1 plus T2 plus so on Tn. So simply I can say here the statement of average speed can be defined. It is the ratio of total distance covered by the body to the total time taken, or any person or object like. So while calculating this, there are two average speed calculation. While doing the solving the problem, there are two conditions are there. First condition, equal time, condition average speed. Second one, unequal time based average speed calculation. While solving the problem, if you understand this difference, then you can solve any problem without any errors. Because most of the students will get confused that what type of problem is given, what they are asking, what type of formula you use. Because we have many types of formulas in the average speed. So according to the classification of equal time and unequal time. First we'll discuss based on equal time. According to equal time, this is the path. A car is traveled on this path. The total distance is S. He covered this total path into two parts. I'm not saying equal or unequal, so just two parts. In these two parts, first part he covered with speed V1. He went some distance with the speed V1. Second part with the speed V2. And it takes some time. In this case, heading is equal time. So the time taken for the first part, how much? Second also same. Here speeds are not same. Suppose if the speeds are same, time is also same, the distance also will be same. But here speeds are different, time is same. So is the distance are same or not? You have to understand that. So in this case, the distance covered in the first part is S1, S2. Both are not equal. It may be, okay, it will be different, right? So to calculate the average speed here, the average speed calculation in this case of equal time, first, how to write the formula. In this, what is given? Speed is given and equal time concept. Equal time concept. If they say the word equal time, if you see that, or if you see the word they are not equal distance, then you have to understand that that is equal time based problem. So if you see equal time, in that case, modification of the formula must be done. So first you write the formula, V average is equal to S1 plus S2 by total distance by total time, that is T1 plus T2 formula, because only we taken two parts. What is S1 here? Distance. But distance is not given, suppose. Time is given, they said equal time. In that case, S1 is not given means you have to replace that one with the other formula. What formula? You have to go for basic formula. What is basic formula? Speed is equal to distance by time. And from this, distance equal to speed into time. This one formula you can use it, right? If you use that formula, what is S1 becomes V1 into T1 plus S2 becomes V2 into T2 by T1 plus T2. So this is the one of the formula we are going to use to calculate the average speed if you know the speeds and times. But the concept is equal time concept. If you observe this, equal time means, okay, that equal time concept we have to apply. The equal time concept, if you apply that, what is the average speed formula will becomes the average is equal to V1 T plus V2 T, T, both are T are there, I taken common here, T by T plus T, that becomes 2T. So according to the equation based, T get cancelled. If you cancel the T, what you are going to get? That is equal to V1 plus V2 by 2. So what is the average speed formula you got, that is v1 plus v2 by 2. That means the total distance covered in two parts, we got v1 plus v2 by 2. It is similar like average of the subjects. Suppose after writing examination, you get the marks. What is the average of marks you got means you will add all the subject marks and you have divided by number of subjects. Similarly, here also total distance we divide into two parts. That's why total speed by two parts. If it is divided into three parts, v1 plus v2 plus v3 by 3, you'll get four parts, v1 plus v2 plus v3, so on. Okay, that means v4 up to v4 by four parts. Like this, you have to solve. So what you need to understand, equal type parameter, the average speed is similar like how we are taking the average values in the mathematics. A small example problem we'll discuss. Example problem. A person covers a total distance in two parts with the speeds 30 km per hour. Don't take 30 here, we'll modify the value. 18 km per hour. And second part he covered with 36 km per hour. In the equal interval of time. What is the average speed? To calculate the average speed, we average. So you need to understand here, nothing is given, only these two values given. So equal interval of time, if you see the word, directly come to the formula for v1 plus v2 by 2 parts. Now v1, v2. What is the value of v1? 18 plus what is the value of v2? 36 by 2. How much you will get? That is nothing but 4054 by 2. That is nothing but 27 km per hour. So in this case, this answer also can be expressed in terms of meter per second. Sometimes they ask the answer in terms of meter per second. So if after converting the 27 km per hour, that is 27 km per hour, 1 km per hour is equal to how many meter per second? That is kilometer per hour. To convert it, 5 by 18 meter per second. So you have to solve this one. 27, 18. Which table will? 3 table. That is 3 nines and 3 6. Again 3 threes are 3 twos are. That is 15 by 2. 15 by 2 means how much? 7.5. Okay, that is 7.5 meter per second. That is V average in terms of meter per second. Sometimes you can solve the problem easily because conversion last step, sometimes it is difficult. So you can do it in the first step. Example, V average is equal to, formula is V1 plus V2 by V1 plus V2 by 2. So what is V1 value? 18 km per hour. So I can write that one 18 into, here only you convert this kilometer per hour into meter per second. Convert here only. If you convert here only, 18 into 5 by 18 plus what is V2? 36. 36 into 5 by 18. Total divided by 2 according to the formula. So what I can cancel here? I can cancel this 18, 18 get cancelled. 18 2 times equal 4. So how much is remaining? You can write as an answer. That is equal to how much? That is 10, because 2 5s are 10 plus that is 10 by 2. How much? Sorry, here the 2 is, there is no 10 here, so we made a mistake here. What is that here? It is not 10. First term is not 10. How much? It is only 5. 5 plus 10 by 15 by 2. 15 by 2 means 7.5 meter per second. So if you do it in this method or in this method, you have to get the same answer, right? So while doing the problem, which is faster way to solve, you choose that method of solving the problem. Okay, on this one you can do the problems some practice. Next, we are going to discuss about unequal time based problem. This is most important, unequal time. unequal time based problem. In the case of unequal time based, this is the concept. A car is traveling on a straight road, covers the total distance into two equal parts. Two equal part means the total distance is S, if you say, is covering first half of the distance with the speed v1, second half of the distance with the speed v. What is the average speed? If you see the question, you can understand that distance is very clearly half of, but speeds are not same, different. If the speeds are same, time also will become same, but speeds are different. That's why what happens, automatically time will be different. So unequal time. In the case of unequal time, how to calculate average speed? V average is equal to, you have to use this basic formula, that is total distance by total time. How many parts we made? 2 parts. That's why formula based, V average is equal to total distance S1 plus S2 by T1 plus T2. This one I am taking as S1, this one I am taking as S2, and the time taken for this in this portion T1, in this case T2. So total distance by total time. Now S1, distance is given half, right? S by 2. So you can write that is S by 2 plus second part is also S by 2 by T1. The time is not given, but you understand that it is not unequal time. So, but speeds are given. So you have to convert this, modify into another values. What is that? Time can be replaced with distance by velocity. T1 can be written as in terms of this. T1 can be written as in terms of distance by speed S1 by V1 plus T2 also can be written as S2 by V2. After writing this one, right, now you can apply V average is equal to total S by 2 plus S by 2 becomes S. Here also S1 becomes S by 2. You take common of this one because S1 is S by 2, S2 is S by 2. I taken common. After taking common, it becomes 1 by V1 plus 1 by V2. Now in this case, what I can cancel here, if you see mathematically, this S will get cancelled. After cancellation, now the average speed formula will becomes like this, that is 1. Okay, so this 2 is which is there, that can be made into numerator. So after writing into the numerator, what I can write, this becomes 2 by 1 by V1 plus 1 by V2. So this expression is calculation of average speed in the case of unequal time, okay, traveling of the any vehicle or particle or any person like this. Okay, so if you convert this formula into, according to your books, most of the books give this formula. After solving this one by taking LCM, after solving you get this one, 2 V1 V2 by V1 plus V2 is the formula. This formula can be used for average speed. Now suppose if you come across a case of, if the total distance is covered by the vehicle in 3 equal parts. How many parts? 3. In that case, how to solve it? Similarly, V average in the case of 3 equal parts. 2 equal parts we got 2. 3 equal parts you get 3. 2 equal parts you got speeds V1, V2. 3 equal parts you get speeds V1, V2, V3. So 3 by 1 by V1 plus 1 by V2 plus 1 by V3. We can write like that. So this is the formula you get in the case of total distance covered by the body in 3 equal parts with different times and different speeds. This is the formula we are going to use. So like this, for the case of in the case of n equal parts, Vn is equal to n by 1 by V1 plus 1 by V2 plus so on 1 by Vn. We can use this formula. Like this, you need to understand how to apply the formulas to solve the problems. This is the most important formula you have to solve it. Now we will have a example problem on this one. Take an example. A vehicle traveling on a road in 3 equal distances. It covers with the speeds of 32 km per hour, not 32, 36 km per hour, you take it, 36 km per hour, and 72 kilometer per hour, 72 kilometer per hour, and 18 kilometer per hour. Equal distance. Calculate the average speed in this case. That's it. They won't give any other information because they given in the question very clearly. A vehicle is covering a total distance in 3 equal parts. 3 equal part means the distance of this one is s by 3. Total distance, if you say as s by 3, s by 3. Under the 3 equal distances with the different speeds means what is different, time will be different. If the time is different, what formula to use? The average speed formula is equal to 3 by 1 by v1 plus 1 by v2 plus 1 by v3 I can use. So before solving, if the answer is given in kilometer per hour, directly you can substitute the values. If the answer is given in meter per second, you have to convert that values into meter per second. So I'm finding the answer in terms of meter per second. For that meter per second, first what I'm doing, v1 value. v1 value how much? That is 36. 36 I'm converting into meter per second. How much? Multiply with 5 by 18. How much you'll get? That is 10 meter per second. That is equal to how much you'll get? 10 meter per second you'll get speed. Right? Now what is v2 value? This v1, sorry. What is v2 value? v2 is 72. 72 into 5 by 18. So how much 18 threes are? 30 plus 24. 18 threes are. If check it for 4 times. 4 times means 40 plus 32. 40 plus 32 is 72. That means it will go for 4 times. That becomes equal to v2 is equal to how much you'll get? That is 20 meter per second. Similarly, what is v3 value? v3 is 18 kilometer per hour. 18 into 5 by 18, if you say 18 get cancelled, that is equal to how much you'll get? v3 is equal to 5 meter per second. So the speed v1, v2, v3 in terms of meter per second you got, that you value substitute here. That means v average is equal to, I can write in terms of 3 by 1 by first value is 10 plus second value is 1 by 20, third value is 1 by 5. Now next part of our solution is solving this calculation. So in this calculation, after solving, so what you are going to get? And remember here, to solve the problem fasterly, generally we have to take LCM, lot of things you have to do. So directly I can write here as like this, 3 into, after taking LCM 10, 25. Okay, you can take it as 10 into 20 into 5 is LCM if you taken by, right? This total LCM I am making into, this total denominator LCM I am taking into numerator here. And after that I am taking LCM in this. So after taking LCM, what I can write, that is combination of, I can write like this, 20 into 5 plus 10 into 5 plus, that is 10 into 20. Don't multiply this one, otherwise it takes long time. So 3 into 10 into 20 into 5 by, now this is how much? Now calculate, that is 100 plus this is 50 plus this is 200. That value will becomes equal to how much it is? Don't multiply in the denominator, 3 into 10 into 20 into 5 by this totally 150, this is 300, 350. Now you can cancel it. What way I can cancel it? Here 0, 0 get cancelled. Now 5 sevens we can cancel. So if we calculate this value, how much you are going to get this one? 3 into 20, that is 60 is left in the denominator, denominator is 7. 60 by 7 meter per second is the answer to the question. You can convert into decimals if you want. So this is the way you have to follow the approach while calculating. So that means what the may, don't, after taking LCM, don't multiply denominator. If you multiply denominator, it becomes more big calculation. Again, you have to go for lengthy, you have to spend more time to solve it. Next, one last problem we'll discuss on this, that is a little bit applicable, okay, application based question. A car is traveling on a road. in that total distance, first half of the distance, it traveled with a speed of 10 meter per second, and the remaining half of the distance, it traveled with the speeds of 20 meter per second, 30 meter per second, remaining half of the distance. Calculate the average speed in this case. This is a question. So here we need to understand here, in the question we have total distance is covered in two parts. In the first part 10 meter per second. In the second part again there are two different speeds. So first total distance, whatever it is given, is taken as two parts, s by 2, s by 2, from here to here. The speed related to the first part I am taking as v1. The speed related to second I am taking as v2. So to calculate the average speed of this one, according to basic formula, V average is equal to V1 plus V2. Sorry, what is the average speed in the case of unequal? This is equal distance means unequal time, right? Unequal time means which formula you use? 2V1 V2, right? So 2 V1 V2 by V1 plus V2 is the formula you use. So V1 value directly 10 we can take, but V2 value we have two values already. How many values? V2 we have two values. So how to take two values? For that we have to calculate the V2 value separately. So I am calculating the V2 value separately. V2 will becomes average speed. In this part, the V2 value will becomes average speed in that part. What is the average speed here? In this total distance, we say this is the total distance covered by the vehicle in two different speeds, but they are not saying it is equal distance. So you have to understand this will be equal time. They mentioned, okay, in the question equal time. If it is not mentioned also, you have to understand that equal time. Unequal distance means equal time it takes. If it is equal time means unequal distances. Like this you have to understand. So here different speeds, different distances means time may be same. So time under the equal time concept, what I can write, average speed is equal to, under the equal time concept, what is the average speed formula? V1 plus V2 by 2. So this will becomes one of the V1 dash, you take it, this you take it as V2 dash. So V2 is equal to becomes average speed in this part, that I can write as V1 dash plus V2 dash by 2. So if you substitute the values of this one, what is V1 dash? V1 dash is equal to 20 meter per second plus what is V2 dash? 30 meter per second by 2. The average value of these two, V2 is equal to, that is 50 by 2, that is nothing but 25 meter per second, the average speed of the vehicle in the second part. Now this V2 value substituted in the first condition, then you will get the required answer. The average speed over a complete path is equal to 2 into, what is V1 value given? 10 meter per second. V2 value given how much? 25 meter per second by, that is 10 plus 25. If you calculate this one, how much you are going to get? I said no, denominator don't multiply. So in the last step you can multiply that one. So that will becomes easy for calculation. Now this value is equal to how much I can write? This is 2 into 10 into 25 by denominator is becomes 35. So here I can cancel with 5. 5 5s, 5 7s. This total value will becomes how much? That is 20. Okay, 2 10 5. 20 into 5, that is nothing but 100. Okay, 100 by 7 meter per second is the answer to the question. So V average is equal to nothing but how much you get? 100 by 7 meter per second. This is a way you have to calculate the answer. If you want to write the final formula, suppose this is a part I taken. The total formula I can write like this. V average is equal to nothing but V1. So V average nothing but is equal to 2V1. In the place of V2 I can write V1 dash plus V2 dash by 2. 2V1 V2 by V1 plus V2. What is V1? V1 only plus what is V2? V2 is equal to again V1 dash plus V2 dash by 2. So either you have to modify the formula or either you have to follow the procedure to understand while solving the problem. Okay, this is one of the models of basic up to average speed. Okay, that's it for this part.